Welcome one and all for today's e-session on Accelerators Incubation Opportunities for Students and Faculties to become early entrepreneurs. We are fortunate to have a very eminent speaker for today's session, Dr. Rajesh Ghongade, Professor at Bharati Vidyapeeth, College of Engineering, Pune, and Director of C-Prop Technologies, LLP. Now, let me take this opportunity to briefly introduce our speaker. Dr. Rajesh Ghongade completed his BE in Electronics and Telecommunication from Savitribai Phule University, Pune in 1993. Thereafter, he completed his master's in 1996. In 2009, he completed his PhD in Artificial Neural Networks from Savitribai Phule University, Pune. In 2009, Dr. Ghongade joined Vishwakarma Institute of Information Technology as a professor and head of EXCC department. Later, he was promoted as the Professor and Dean of Quality Assurance. In 2017, Dr. Ghongade joined Bharati Vidyapeeth, College of Engineering, Pune as Professor in EXCC Department. Dr. Ghongade has 3 Indian patents and 6 copyrights to his credit. Currently, he is leading 5 consultancy projects. One of the notable product developed is Concrete Maturity Meter. Dr. Ghongade has led the team in developing various softwares such as Discrete Design Factory, Power Transform Design 50 Hz, to name a few. He has also led the team to develop educational tools in Windows platform, namely Basic Linear Power Supply Design, Amplifier Design, etc., and in developing 14 education apps in Android platform, of which 7 are available on Google Play Store. He has a total of 30 plus years of experience in academia and industry, of which 12 plus years in research. Dr. Ghongade has around 50 plus publications to his credit in the areas of soft computing, analog and embedded system design, biomedical signal processing, PCB design, and IoT. He is also a reviewer for 2 journals, namely Computers in Biology and Medicine in Elsevier and Journal of Image Processing, IET. It is our honor and privilege to have such an experienced speaker with us. Now, on behalf of Visit IIC, I would request Professor Rajesh to take over the session. Over to you, sir.
Yeah, thank you. Let me just see how I can share my presentation. Uh, we normally don't use Google Meet, so a little bit jugglery we'll have to do. Okay. Just a moment, please. Okay, is the screen visible? Hello?
Yes, sir. Yes, sir. One minute.
Just a moment.
Yes, sir.
I just share the
Yes,
window itself
Yes, sir.
so that all right, should be visible now.
Yes.
Hello?
Yes, sir. It is visible.
Okay, good morning to all. Thank you for giving me an opportunity to speak to you. Now, for quite a long time, I've been talking about technical things, lecturing various things and all that, with the perspective of a professor. This is the first opportunity where I'll be using to say something about share my experience about uh, being a director of a company, specifically an entrepreneur for that matter. Am I audible?
Yes, sir.
Okay. So let us first of all tell me about. Let me tell you about the company itself. The company is called C-Prop Technologies LLP. Mr. Hemant Donde and myself, we are the founding partners and the directors of the company. We have a couple of engineers working with us as as you can see on the screen. Now, let us come to the product. Basically, my intention today is to walk you all through through our experiences that we faced during the evolution of the product, making from product idea to from idea to product design. That is what I have in mind today. So I'll share along with you all the experiences that we have had, the challenges that we have been facing, and we still are facing, that sort of things. Okay, so the product here is called as concrete maturity meter. As you can see on the screen, that it is an interdisciplinary product specific work, by the way. It's targeted towards concrete industry, and our meter does a specific job of solving a certain problem. What that problem is, let us first of all see. Now, you must have seen various different construction sites with different, different numbers of cubes, concrete cubes being cast. Now, the conventional method of testing the concrete strength, or the strength that has been achieved by the concrete after curing for so many days, so many hours, uh, the traditional method is that what they do is they cast cubes of the similar concrete mix, and correspondingly what they do is they keep on breaking the cubes after certain duration of time. Let us say after 2 days, 4 days, 8 days, and so on and so forth. Now, the strength that is achieved by that concrete block or cube, they say that it is approximately, or it's an indication of the concrete strength, or the strength that has been achieved or the gained by the concrete when you cast it in the slab. Now, there itself there is a current. There itself it's a big, let us say, approximation, a very risky approximation being taking place here for such a long time. For example, your concrete mix can be the concrete, the cube basically that you are trying to cure is being cured in different laboratory conditions, whereas whereas the concrete which is put on the slab, that is exposed to the environment. So the curing conditions are different. So it is not necessary that the concrete in the slab has achieved the same kind of strength that has been achieved by the cube. Secondly, the mass of the cube itself is very, very small as compared to the mass of the slab, and there actually the difference may arise. And that is the reason why people, what they do, they overrate, or let us say the tolerance that they use is much more, and that is the reason a lot of wastage is there. Cement concrete, the cement that goes into the mix is different. I mean, maybe more than that is required, and so on and so forth. So they actually uh, overrate it, and correspondingly there may be some kind of, let us say, wastage of material unnecessarily. Okay, overrated components will again cost you much more. In addition to that, there is a wastage of the cubes that have been cast. Again, real time strength is not visible. The cubes are broken at different intervals. So after 4 days, you'll be able to come to know the actual strength. After 8 days, and so on and so forth. There is no system for real time measurement. The solution that we have provided here is what is called as a concrete maturity meter. Now the technique is pretty old. It is 40 years old, but the technology has given us an edge to manifest that, use that technology in the current context. With the advent of IoT and all those kinds of platforms, it is easy for us to uh, get all this data in the real time. Now, what kind of decisions? I mean, the solution, it says that the data is valuable for taking on-site confident and timely decisions. Decisions for what? Decisions for de-shuttering. De-shuttering is a process where you remove all the support once the concrete sets properly. Once it gains a particular value of strength, then you can de-shutter it. But there is a lot of logistics going on around with this also. So what our product offers is all these advantages, like you can take timely decisions. You can say that with confidence, you can say that this is the strength that has been achieved, and obviously the cube tests will reduce by 50%. You can rely on the system and not on the cubes for for estimating the concrete strength. Now, the very first thing that I would like to tell all of you is that how we started. Basically, it's an idea. So whenever an idea comes to your mind, uh, you have to first of all evaluate whether it goes. All this comes under what is called as the intellectual property rights. So whether it classifies into a patent or a copyright or a trademark is a little bit different, but specifically when you're talking about patent is not something that you can, you can simply imagine and then apply for. Patent is, as I've referred to one website over here, it is a technical invention such as chemical compositions, pharmaceutical drugs, mechanical process, complex machinery, in our context, electronics design, okay, which are new, unique, and usable in some type of industry. So these three words are very, very important: new, unique, and usable. So you have to identify whether your idea belongs to which kind of IPR. Then you have the copyright. Copyright actually takes care of, you know, it's intellectually created works like artistic or literary or even music, movies, software code. So your software code goes into this particular category. And finally, the trademark. So it's a word, phrase, or design. Design means a pattern or a combination that will identify your good or your basically your product or services and will be distinguished from the other goods or services offered by other people. Now, uh, basically, you have to first of all identify all these things, and correspondingly, you have to plan accordingly to apply for these patent, copyright, or trademarks. Now, in our case, it was a machine. It was a kind of a design, a unique design. Uh, of course, it's not unique in the world, but again, as I said, design can, a particular solution can be, you can solve a particular problem in various different ways. Again, an innovative way qualifies for a patent. So even though there are huge players uh, worldwide for concrete maturity meters, we are not the only ones manufacturing that. There is some big company called as Giatec, which has been in the market for around last 8-10 years, but they have certain ways of doing the same thing, and we have found out a different way of doing the same thing. And we have now, I'm proud to say that we are the only indigenous manufacturers of concrete maturity meter as far as India or India subcontinent is concerned. So the point here is that we first of all try to protect our IPR. Protection is very, very important, because you see, it's not that you are the only person who are getting the same idea. It is quite possible that simultaneously many people get the ideas at nearly about the same time. A classical example is the idea that has been the patent. Basically, there was a patent war between the who is the inventor of the microelectronic chip or integrated circuit, whether it was Jack Kilby or Gordon. That kind of war was there for a long time, because both these people got the idea nearly at the same time. So uh, so that is basically the problem. So you have to first of all protect your IPR by either applying for a patent. Now, patent doesn't only mean idea. You have to first of all make a prototype, properly test it, and then probably simultaneously you can apply for a patent. Now, many things are obscure as far as copyright is concerned, because what does copyright basically? What we had different components. Like, it's a product, so hardware design was there, software was there, which was used for analysis and prediction. We are going to go to that slide after some time, and then finally the entire product. So we had to apply for all these three so that it can be protected. This is how the product actually got evolved. You can see here that in 2013 the idea was floated by my partner, Dr. Hemant Dhonde, because he has been working on concrete maturity meter for quite a long time in US. So he said that there is no indigenous product which is low cost, offering low cost to our Indian scenario. So he came out with this idea and approached me for designing the entire system. So we started off in a very simple way. the very first model was very, very primitive because it had got different type of sensors, and it was just and came out with some certain, still the prototypes. As you can see, it's a development of the prototypes where we had no access to, we had no provision to store the data. We had no, no provision for uh, battery operation. Like it was not battery operated. It was directly connected to some power supply, and so on and so forth. So we've gradually the entire thing got completely revamped in 2017-18, where we came out with actually changed the architecture completely. Now these are all let us say experimental models which had a lot of problems. Like in 2013 and on, all the outreach, or let us say the penetration of internet facilities in India were very, very, it just started. And internet facility was required for us to transmit the data from the site to our some other, maybe cloud concept was also not very popular then. So we had to somehow transfer the data to the user end remotely. So there was a big problem there. And in 2007, the opportunity came up with various different platforms like Amazon Web Services and all those kind of things. Wi-Fi enabled SOCs came rather into the market, and so we could make use of such things. And then we completely changed the design to a very compact and elegant design, which was now IoT capable. Now, backbone is IoT, means the backbone is internet. So naturally, we had to think of all those things. At the same time, we had to come out with an Android-based application. But these were all very primitive. Okay. So we finally, in 2021 or 2021, we came out with a marketable product like this. So as you can see, the journey you started in 2013, ended in 2000. It's of course the journey is still going on, but a marketable product we were able to present in the year 2021. So you can see some almost 7-8 years we had already spent in just evolving the product. So basically, what people normally think is that, okay, I get a very nice idea, and within 6 months, within 1 year, I can immediately make a product out of it. No, there are various different considerations that you have to give before you finally make a final copy, which is marketable, which is in the product form. So we had various different hardware challenges along the way. Now, the basic idea, the students normally they don't have this idea because they have normally what they do is they think of the design as a project. Now, there is a huge difference between a project, a prototype, and a product. So, the very first step, as far as the students are concerned, of course, they are trained in that way, so they think only about the project. Now, when you go from project, what basically is the difference? There are various different hardware challenges. In our case rather, at the component level, we had lots of challenges. Like, okay, you have the idea, you have even the prototype, and once you go for making it into a full-fledged, full-blown product, lot of things like reliability. The component reliability was a major issue because these are all time critical kind of, and of course, critical decisions would be, we would expect that people would take critical decisions based on our system. So the topmost priority was given to reliability. If somehow the meter stopped working, if one of the components failed, then the entire run. Now, let me tell you one thing, that this particular meter has to be used in two different modes. The first mode is calibration and the second mode is deployment. So you run the calibration for, let us say, a few days, and then use the same calibration data for deployment purposes. Now, if at any one particular stage, if the meter fails, for example, if the meter fails in calibration phase itself, their entire run will go waste. So this is a very, very critical issue which had to be addressed from the point of view of reliability. So reliable components, basically very reliable components we had to go for. We have to think about the availability of such components. One or two components for making a project or a prototype is fine, but when you start thinking of mass production, in that case, availability of the components and the guarantee to get required number of components is also very, very important. Then PCB size was also one of the major challenges, because this was to be kept on the side. Obviously the PCB size was very, very critical. Connectivity was the most, one of the most important, and the most hard thing for us to solve, because Wi-Fi is not yet frequently used on sites, specifically on construction sites. So we had to make sure that the connectivity was with the help of Wi-Fi. We had to make sure that even in spite of loss of connectivity, the data is not lost. And once again the connectivity is established, our meter would, um, let us say, refresh all the readings. Whatever readings were missed, just a minute. Okay, I'm sorry. Okay, so I was talking about the connectivity issue, and this connectivity was one of the major problems with this particular product. Cost, obviously, the cost was one of the most critical things, because as it is, people don't want to invest something which they are already acquainted with for the last 40, 45, 50 years, and they don't want to suddenly change. That is the very first inertia. The second inertia is the cost. You don't want to invest in that. So the cost had to be kept to minimum. Third part is the last one is the traceability. Now, what do you mean by traceability is there are a lot of sensors, 4 sensors per meter, and each meter has to have unique identity. Each sensor is to have unique sensor ID. So we had to select certain sensors, not any sensors. We had to select a sensor which was capable of giving us some kind of traceability, like it must be having its own unique ID. So all these things we had to think about when we went from uh, prototyping to the product itself. Then there were software challenges also. I'm actually it took us a long time. The reason for that is I was the only person from electronics and computers to manage all these things, to write all these things. In fact, this software has been written by me, the hardware has been designed by me, the firmware has been written by me. So it was like a one man job for this particular thing. My partner was taking care of the civil side. So it was very difficult to, um, let us say, um, get all the things together, because I had to do this all parallelly. So what were the software challenges specifically? Ergonomics. Ergonomics, what the definition of ergonomics is, the ease of use. So basically, the target people, that the clients, they were civil engineers, and most of them were not really into computers and all that. So it should have been very easy. The software should be very easy for them to use. It should not be that it is very complex and there are a couple of large number of parameters for them to adjust. Otherwise, they will simply be not be able to use the software. So ergonomics was the most important, I mean, the priority over there. Analysis and prediction. So what type of analysis was supposed to be generated, or let us say carried out by the software, and based on that what type of prediction would have been would be required, which was useful to these people. So we had to think about all these things there. uh, my colleague, he came into picture where he had a perspective from civil engineering point of view. So obviously I had to write the design, I have to write the software, I have to write the uh, code in such a way that uh, some meaningful result was given to these people. Document generation. Now, the document generation is one of the most important. Documentation is one of the most important things when you go to any industry. They have to have some certain proofs as to, okay, this is what we got. This was the documentation. It was time stamped, etc., etc. So that kind of printing ability of whatever results that were generated, that also we had to take into consideration. Security was one of the most important issues. Like all these target clients, they have their own unique mixture of concrete. The concrete mix, and they don't want to expose it to the external world. And obviously, we had to use a common platform, Amazon platform for Amazon Web Services for the data communication and intermediate storage. So obviously, security was a very important issue for that. So we had to create desktop apps, Android apps, and there was something called as a meter configuration app. So all this was simultaneously carried out, and that is the reason basically. But the one advantage, however, was that there was kind of communication gap between this, like what was exactly required in desktop app, what was exactly required in Android app, and so on and so forth. There was no gap because a single person, that is myself, uh, I carried out the process of designing all these things. But in real life, I won't recommend that because it becomes a little bit um, difficult later on to maintain all the code if it is done by a single person. So you have to basically look out for a teamwork. Okay, gather your own team, prepare the team members, and correspondingly there has to be some kind of a synchronism between the person who is developing the desktop app and the person who is developing the Android app. So obviously, this kind of thing has to be taken into consideration. Again, licensing. Anybody can use this software if it is free. So what we did was we implemented the licensing, very primitive licensing scheme. Basically, the idea here is that it's a system. It's not only that meter which is carrying out everything. It is the software also, which is in fact giving us the idea of the concrete maturity that has been achieved so far. One of the most difficult tasks was the enclosure requirement. Now, as you can see, if it is, you can see clearly over here that the meter which is being deployed in worst kind of conditions, okay, where a lot of dust is going to be there, where a lot of sand is going to be there, where a lot of water is going to be there, where people, the lowest rung people, they really are not careful about these things. So it is quite possible that they may step on it, they may pour water on it, cement on it, whatever. So it has to be protected by some certain IP standard. Okay, I hope you know about the IP standard. So our product basically conforms to IP68 rating. Obviously, as I said, rough handling, and there were a lot of sensors coming out of it. So obviously, the connectors were required to be selected in a particular way so that they could, let us say, bear this particular harsh environment of rough handling and still be reliably used. So this was one of the major challenges that we had faced while converting this into a product. Obviously, budgetary challenges were the most, because making a prototype is very easy, but when you try to go from prototyping to the product design, and obviously when you try to scale it up, you have to go for you have to look out for the seed funding. We already have approached a few investors, obviously not directly. We have got in touch with some certain innovation cells from COEP, my alma mater, and now will be getting some investors. Seed funding probably would be available from there. We'll be applying for. We have already applied for government startup fundings and all those kind of things. One of the most important challenges that we have to face was the employee expenses. Now the thing is, this it's a vicious circle. If you want to scale up things, you require more manpower. If you require more manpower, you require a lot of funds. And where are these funds going to come from? Unless and until you scale it up, unless and until you go for target large number of clients. So it's a vicious circle, and it can only be broken by seed funding. So basically, we are looking out for that seed funding. Our current clients are L&T. They have been using it. Space Tech. This is a company from Dubai. SDPL is a very large company, a construction company, and so on and so forth. I would like to share a success story by our client. Let me see if I can run the YouTube directly from here. Just a moment. I will reshare. Just a moment, please. Okay, are you able to see the YouTube video?
Yes, sir. It is audible also.
Okay. Let me just brief about this. That there was some mission floated by L&T that they were supposed to complete 96 flats in a matter of 96 days. So they are calling it as Mission 96. Here you can see they have mentioned the concrete sin monitoring in real time. Let me just go a few. So these are the software screenshots that they've used. This. as you can see that it was a very time critical kind of a mission. Let me just go back to my slides. Okay. So the point here is that they had a very time critical kind of a mission, and our meters actually saved 4 hours per day for them. So that was quite significant for them, and they have appreciated it that okay, such types of meters will definitely be useful in time critical kind of decisions and projects. So, coming to the end of the slides, challenges for scaling up and some possible solutions. We have to go for cloud storage and management. So again, as you can see, scaling up requires more, let us say, powerful kind of storage management. Web-based application we are trying to incorporate. Data security, okay, security from the point of view of the user is there, but the data security is still not there. Anybody getting access to the website, to the IP, might get hold of the some of the data. Of course, the critical data is already encrypted, so we don't have any problem over there. But still, people may demand data security in totality. Again, subscription management we are thinking of going for, and finally, the funds. We are just planning to go for more and more funds. So that is basically all from my side. Um, I I rather intend this to be more of an interactive session. So um, yes, the forum is open for questions. That is probably, I think most of you are more interested rather than looking at what has happened. So yes, any questions that I think most of you have in mind, most of the young entrepreneurs may have in mind about.
Good morning, sir.
Good morning. Yes.
Good morning, sir. I'm Principal Mrs. Nair. Very, very, very inspiring. Very inspiring. I think I have a doubt.
Sure,
I
ma'am.
think it is an ideal thing for our staff members to hear. This session is very good. I congratulate IIC also for arranging this session. And I have a doubt whether you have any previous experience in designing such things, or you started with only this.
No, ma'am. Like I said, electronics and telecommunication. Rather, electronics is my hobby.
Huh.
Uh, it's just like it's a hobby turned profession.
Huh.
And since I graduated from COEP back in 1993, we had lots of opportunities to go into the industry. So I went into the industry and spent my 1 year over there to get insight of what exactly goes on in the industry. After that, I had a lot of ideas with me. So I said the best possible way that I can explore is join academics. So I left my job, which was a campus placement, and I turned up with I went into full-time academics. But then, as an engineer, I always had one wish in mind, that one wish that I have, that one of my products should be there in the market. So that is what all inspired me to do this. And of course, I was very much active. I'm still am active in a lot of development kind of things, like in projects, mini projects. I'm completely into that. Research just happened to be a side thing. As somebody has mentioned, my specialization is artificial neural networks. So that actually was a different thing altogether. Research and development. So development is a major focus for me. So correspondingly, I said, I mean, that is the reason why I said, let us try this, let us do this. I gained some insights. For a few years, I've been doing consultancy work also. So that is where basically all this started. And I say, I'll say one thing, that each one of us as faculty members is capable of doing this. It's not a rocket science. The only thing that is required is some kind of passion, some kind of dedication, and of course hard work. So if these three things come together, I'll say anything is possible. Yeah, we had quite a lot of challenges. Like I'm hardcore engineer, so we lack those business insights, and that is where we were a little bit struggling for some time to launch our product. Yes, ma'am. I hope I've answered your question.
Yes. So, how did you find the market? You went around and approached the people, or you have pitched, you have gone for
No,
some
yeah.
presentation or something?
Let me clarify that. Since my colleague, my another partner he's from civil engineering section, he has got the insight of this market. My role was completely into the development of the system. So I should not say anything as far as the market is concerned. But yes, we didn't go around anywhere. But he felt that lot of there was a lot of change which is expected to occur in civil engineering, construction industry also, and there were a lot of problems already there, like as I said, de-shuttering problems. No, you must have seen that there are so many disasters, mishaps which has already occurred. That is because of the incorrect concrete mix being used, or maybe the shuttering was removed too early, that made the slab to collapse and all those kind of things. So these kinds of things. I mean, basically, we had this requirement. Everybody had this requirement because, as I said, there was no direct way of measuring the concrete meters, concrete strength in megapascals. It was a completely indirect method. So he felt that in US they had already started using that 2 decades back. So he wanted to bring the same idea into industry in the Indian scenario. So that is where everything started. And basically, he had a lot of contacts in the because he also was in academics, but at the same time, again, just like me, he was doing consultancy work and all those kinds of things. So people did approach him for such a kind of equipment. So we knew that there was a huge market potential. And one thing which is also important over here is that people cannot, these civil contractors, they cannot fake anything. That was one of the major challenges. This is totally an unethical thing for them to do, that they're using one mix for the slab and another mix for the cubes, and then prove that, okay, they have gained the strength. But practically that doesn't happen. Many times it so happens that the concrete which is actually poured on the slab is totally of a different mix, which has different characteristics and all together. So quality of the work, reliability of the work is again compromised. So our system ensures that it doesn't happen. That was one important thing. So all in all, my partner, Dr. Hemant Dhunde, he came out, he said that there is a huge market potential. He did all that market analysis part. I'm sorry, I'll not be able to share that because I don't have that kind of data with me, because I'm completely into this, the development of hardware and software and management of clouds and all those kind of things. So I'm not a marketing guy. So specifically, I didn't find, what I gathered from him was like the various different talks when he was pitching to the clients and investors and all those kind of things. Some tidbits which I gathered, and that is what I'm sharing with you. So market requirement is a must. Basically, if you have a very good idea, if you have thinking of a very good product, but it doesn't have a market, or if the market is not ready yet, still we have the problem. Like there is a lot of inertia. People don't want to change. So first, what we had to do was we had to let us say convince them of the advantages of our system, and then correspondingly they say, okay, we can demonstrate this product. And then once that is what happened with L&T also. We had to give one of the meters free just like that for demonstration purposes.
Okay.
And once they were confident, then now they are actually claiming it, that okay, like this is one of the automation that we have used. This is basically what we are. The entire industry is being driven towards IoT, industry 4.0. So this also comes under the same category, I presume.
Okay. So you started actually the first version, crude version, 2013.
Yeah.
Then when could you register actually the company finally?
We could register the company just last year in 2020. 21, okay. Sorry, in 21.
21, 8 years.
Because there were certain problems associated with that. Like first of all, who is going to invest? Do I have the time to invest my my time? I'm working here full time, so those things were already there. Like, how do we go about it? So we had planned, we required planning for about 1.5 years, and then said, okay, now it is feasible for us to launch the company and then start marketing our meter.
So you have not outsourced any part of even cover
Not,
design,
not,
kuch bhi nahi.
not a single thing.
Not a single. That is
Not a
very
single.
incredible
And that
because
is the reason. Probably that is the reason why you see that the GUI, the Android app, they are a little bit crude. They are not, professional enough, because I have been doing that
yes, yes,
myself.
yes.
Uh, so we are actually thinking of making it into a, the facelift and all those kind of things. But first of all, we have to prove the functionality.
Yes, yes, yes. I mean,
Yeah.
now that you have got acceptance from industry,
Right.
probably now you can
Definitely.
look at all those things.
So that we can employ some specialists, like,
Yes,
it's
exactly.
like jack of all. That's what I've been doing.
Yes, yes,
So
yes,
it's a time
exactly.
for us to approach the masters, the
Yes,
specialists for, let us say, Android app development and web-based app and all those kinds of things.
okay. Some student has got a doubt.
Yeah, it is not a mechanical product. I'll say it's not a mechanical product. First of all, of course, I couldn't get his complete question. Can you please phrase it for me?
Johan, you yourself can ask.
Johan, please unmute, Johan.
Hello.
Yeah,
Yes,
please go
yes.
ahead.
Sir, I had a doubt that will it have any error? Like, the people when they use it, will there be any percentage of error?
Definitely, very good question. Yeah, I basically this is all in compliance with what is called as the standard. Just like our IEEE standards, there are some ASC standards for concreting, and what they do is they have actually mentioned this technique, that they said that this is the alternative technique which has been approved by ASC, and they actually allow an error of 15%. Whereas our whatever we have seen is that error is well within 10%. So it actually is in compliance with the ASC standards. So yes, of course, you cannot say that it is error free. Definitely. See, the basic idea here is that we are using the calibration data, we are trying to predict. So obviously it is going to have some error of its own. Maybe the error must have crept in because of maybe the sensor not being precise, maybe the data, no, the sensor itself may not be accurate enough. Of course, we have ensured that the sensor accuracy is within plus minus 0.5 degrees Celsius, but of course, it's a temperature sensor. I'm not exposed so many things, but yeah, we can claim that we have already seen this. The time that we required for it to bring to the market, we had tested it thoroughly at our end with the real site testing and all those kind of things. So we found out that the error was well within 10%. Even 10% is a kind of an extreme. It was well within 7, 8, 6, 7%, which is acceptable by ASC standards. So it is complying to that.
Okay, sir. Thank you.
Sure. Yes, I'm expecting questions.
Yes.
Good afternoon, sir. Asma
Yeah.
this side. I have a query. So,
Sure.
as a faculty, being a faculty full-time professional, what are the challenges you have faced in incorporating a company and then going ahead
Yeah.
with such
So
a big, huge project?
very interesting question. You cannot compromise with your daily job, right? Like, I'm a full-time faculty member, so I have to do all my tasks here. That's fine. So obviously, what I had to do was work in the weekends. As soon as I get home, I start working. That is, time is the only challenge for a faculty member. Time is the only challenge. Fortunately, my family supports me. Doesn't involve me in any menial tasks, some routine tasks. So I'm thankful to my family also. Uh, but yeah, I mean, you have to be passionate about it. That's the only thing. And once it happens, even the time is not a bar for you. Okay, you can create time, so as to say. So that was one of the major challenges. Time management of time was major challenge. Another challenge was actually it was not a challenge. Why? Because I have a habit of learning new things every 6 7 months, 8 months. I get bored with the previous things that I've learned and go for a new thing. So all these new things, they club together, they add to your knowledge base, and then you can ultimately say, okay, this is what I can use here. This is what I can use here. So I've learned, I mean, I've been doing Android programming from 2012, right from 2012. Then desktop applications also I've been doing. As I said, many copyrights I have registered. Um, at the same time, uh, being an electronics faculty, I've I've designed a couple of softwares for design of bipolar junction transistor biasing and uh, amplifier design, operational amplifier circuits design. I've automated all those things. So while doing that, there was a practice of writing software for desktop and all those kind of things. So that kind of experience definitely helped me into all these things. And of course, I have created my own laboratory. Apart from companies is different, but I have my own laboratory at home. I've invested about 3.5 lakh rupees just to get a lot of sensors and actuators, um, development boards, and all those kinds of things. So of course, I have to put in my own money for my own lab. It's a very small. It cannot be called as a lab. It's just a collection of some components. But in spite of that, I did that for the last 3 4 years. And obviously that basically what happens is, once you have access to all these components at your home at your own time, you tend to work with it a lot and obviously try to solve problems. And so time doesn't remain a barrier that way. Of course, my management also is very helpful. My principal is also she's way too supportive for all these things. In fact, it is expected now that teachers should not only teach; they should actually come out with products which you can claim to, which can sustain in the market. Because unless and until you go through that product development cycle, how will you teach the students to become entrepreneurs? So that is one of the challenges that a modern teacher, engineering teacher, has to face, in addition to research and all those things. Of course, balancing research. See, when I did this, my research component was it got slightly it got sidelined. I must agree with that. You cannot do everything at the same time. So I had to sideline my, again, artificial neural networks is again one of my passions. So, but I had to sideline it just for this. You have to make time. That's it. That's what I'll say. And of course, keep on improving your competency. Problem with the engineering teachers is that, sorry to be so blatant in the public forum, but the competency levels are not really good. Please don't misunderstand competency with the let us say the intelligence. Competency can be improved at any point in life, and that is what I've been trying to do. Improve your competency. Go on improving your competency. Keep on learning new things, implementing new things, and you can simply do that very easily. Okay, if you're teaching a subject for the second time, try to teach it in a slightly different way. Try to do something about it. Try to automate things. Try to write softwares for now. One of the basic problems which we face is when we give numerical problems in the examinations or for the assignments. Every time you have a design, separate specification for the design, you have to calculate everything, right? So you cannot give large number of assignments. So what I've done is I've created a software for that. Just plug in the specifications, it will give you the result. So I can create a lot of numerical assignments based on simple things. And of course, this helps. I mean, it's like reducing your time using automation to reduce the efforts, time, and utilize the time somewhere else, like in productivity. Okay.
Thank you, sir. So there is one question from Dhruva Chaudhary.
Sure.
Yeah. So he wished to inform you that being in the computer field, okay, and without knowing anything about mechanical and biotechnology devices. So is it necessary that you should have a basic understanding of that field before entering into it?
Definitely. I'll say that you need not be a master in that, but you should at least have a working knowledge of whatever your whatever new thing that you're trying to go into. Now, one of my students, he is a obviously he's also an entrepreneur. He has got his own company, but somehow he got into food industry. Now, for him to go into food industry, he has to know so many things about food. You cannot directly blindly step in, and sometimes at one fine morning you can say, okay, I can work in this field, but this field is not known to me, but let's still start working on that. No, a lot of homework has to be done. And of course, as it is said, instant success needs time. That's the thing. So you have to invest a lot of efforts, time, hard work. Obviously, computer. See, now this fellow who has asked the question, he's from computer background. But yes, what is ultimately computer engineering, and what does it cater to? It caters to some certain problem solving. Okay, using computer as a tool, we are trying to solve a particular problem. Now, you have to know the nature of the problem first, right? It can be a mechanical problem, it can anything, as a matter of fact. So you have to know. Like I didn't have any clue about civil engineering. We had only one subject at the first year, civil and construction, whatever, service construction and surveying, and that was it. But later on, I had to sit with that fellow, my friend over there, who is an expert in concrete and all that, and I have to understand what is the process. Okay, what goes on inside, what kind of orchestra goes on inside the chemical components and all those kind of things, the enthalpy and all those things. Now I've started to understand, but then I need not really go into those details. I just need to know the working details. Okay, so what is the type of output that I'm going to get, and how am I going to process that output, and finally, let us say, present it in some kind of a meaningful form. That is what is expected. Of course, you should not consider anything as a black box. This is the worst thing that can ever happen to an engineer. That he thinks that this is a black box, input de do, yahan pe output le lo. No. That is the worst thing that would happen. You have to know some things, at least the working knowledge you should. I hope I have answered that question.
Yes, sir. Any questions, participants?
Now, my basic focus would be for not only the students, faculty members. How will you, I mean, let me see how I can put it. With your tight schedule of NBA and NAC and all such sort of things, I know it's very, very tough, but I'll say at least take one project. Now, embedded systems have become so easy with Arduino IDE and Arduino framework. So at least take one small project and try to do it individually. Don't involve any student. Okay, don't involve anybody. Just try to do it on your own. And you will ultimately see that your competency level slowly improves. You're confident enough. And once you know, once you have one particular, let us say, what is ultimately what is an Arduino board? It is a development board with a microcontroller at Mega 388P and so on and so forth. So once you have the tool to solve a problem, let any problem be there. You have the tool to solve it. So start working with that point, from that point of view. That is what I'll say. at least one in a semester. And Arduino development boards, the clones are very, very cheap, like 200, 300 rupees, you get a nano. Even other chips are also very easily available, and they are not very pricey enough. Another important thing, in fact, I like to share that it's not a good thing, but what I did in this product is right from the sensor interface to the firmware development, hardware architecture, even the PCB also was designed by me. I also like PCB designing. I have a couple of videos on YouTube. You can just, people who are interested in PCB design can go and have a look at it. So I can claim that this is a complete end-to-end product. Even the cloud, the software which runs in the cloud is also been written by me. So everything is like end-to-end. I can claim that it's my product. Well, I should not claim it's my product, it's our product. But yes, there was no other intervention from anyone. So I didn't have to depend on anyone. That's the best part of it. Otherwise, it becomes very difficult to have a synchronism between different team members. Fortunately or unfortunately, whatever you like to say, I didn't require any assistance over there. But yes, it took a toll on me. It took a lot of time, a lot of iterations. Still, customers tell us, okay, this is what we want. The X scale has to be expanded. Y scale has to be expanded. So things keep on coming around like that. So still, the development is still going on. Yes.
Thank you, sir. I suppose there are no questions further ahead, but I assure you that we'll take up your task of picking up a project and trying it on our own. A minute. Yeah, sir.
There is a question here.
Yes, there is one, sir. Yes. Anchal. Sir, how do you solve your error?
I'm not able to understand this question.
Anchal, please unmute. We are not clear about your question. Anchal, please unmute and do elaborate it. Anchal, please unmute. Yes.
Hello.
Anchal, please unmute. We are waiting for you all. Waiting for you, Anchal.
She seems she has a problem.
Yes, sir. I think so.
Okay, she can just type it more in a more elaborate way.
Okay.
System error.
Okay.
What kind of system error? Again, it's a little bit vague for me. I'm sorry. Can you rephrase the question? Whether it is systematic error or what, instrumental error, I don't know. I'm not sure on what you're trying to ask. Software error. That is called debugging, my dear. Isn't it? Am I right?
Anchal, please unmute. Okay. Yes, sir.
So like you debug it as you would debug any other software. Isn't it? The framework which I have used is slightly different, I'll tell you. If you want to use the framework, same kind of framework, I'll tell you to go to, again, my YouTube channel is there. And I have there I have a video for fundamental building blocks of IoT. You can watch that video, and there I've explained, at least I've introduced, let us say, not explained properly, but introduced the framework which I've used for the entire product making, right from Arduino, let us say Arduino firmware development, Android development, and desktop app development. All can happen in the same kind of similar kind of framework, which is called as B4X. So for those who are interested in full-fledged IoT solutions, V4X is a very good choice for that. And that is what I've been using. I didn't use C language, I didn't use Python, nothing. I didn't use Java. But ultimately it's like, you can just go through that website and see v4x.com. And the interesting thing is that all these tools are free. So yes, I had an interactive development environment just like any other software, and so the debugging was quite possible.
Yes, sir. Sir, I just shared your YouTube channel.
Okay, thank you. Thank you, sir.
Yeah. So, shall we proceed ahead, sir?
Sure.
Yeah. Okay. So, Ajay. Okay, I think he is not audible. 1 minute, sir. I'll just share the tab. Yeah. Okay. So, on behalf of Visit IIC, I, Vifna CS, Assistant Professor and IIC member, is honored to give the vote of thanks for the inspiring talk on accelerators, incubation opportunities for faculties and students to become early entrepreneurs by Dr. Rajesh Ghongade. It has been very encouraging for all of us present here. We are thankful to Dr. Rajesh for taking out time from his hectic schedule to be with us today and enlighten our knowledge in the respective domain. I would like to highlight few points, that is, sir explained the entire process of product development and the dedication and passion and even the perseverance that is required throughout the process. An insight into the challenges during the process being a faculty member, and also insisting each one of us to keep on improving our competency. I assure that we will take up your task in picking up a project and try it on our own. I would like to thank our principal, Dr. G.M. Nair, and Vice Principal, Dr. Vijayalakshmi ma'am, Vice President of Visit IIC, Dr. Nadir Charnia, Convener of Visit IIC, Dr. Grisha Bhatia, for without whose initiation, this would not have taken place. I would also like to thank all the Visit staff and scholars for being present here to make this event a success. Participants are required to fill the feedback form. Yeah. 1 minute, sir. I'll just paste it also. Thank you, sir.
Thank you so much.
Yeah. So the feedback form is also there in the chat box. Please fill the form. Thank you very much, sir.
Okay, thank you once again. Thank you, Charnia sir.
Sir, I would like to add on, sir is facing some technical issues at his end, so that he's not audible. So on behalf of Nadir sir also, I'm emphasizing that the session was very beautiful and everyone has taken it in the right sense and would like to take it ahead, following your path. Thank you, sir.
Thank you.
Thank you very much, sir. Thank you.
Thank you. I leave the meeting now.
1 minute, sir. Sir, your student Rasika ma'am is there online.
Rasika?
Hello.
Hello.
Hello, sir. Can you
Yes,
see me,
please.
sir?
Go ahead, please.
Yes, actually, sir, I'm your student from Batu. Do you
From
do you
Batu?
remember me?
Really?
You
You must have
taught
changed
us
a lot.
physics
You
in
must have changed a lot.
Accelerator.
Your appearance must have changed a lot, it seems. Otherwise, I would have recognized you. Rasika? Hello.
Yes, sir. Ingrid madam and myself, we were traveling from Mahad.
Okay. Yeah. I remember now.
Yes.
All right. How are
Sir,
you
you
doing?
are part of VLSI as well.
Okay.
VLSI, IC and IC. Dhanashri Pote, you must be remembering, no?
Yeah. You're from her batch, or what?
Yes, sir.
Okay. Dhanashri is
I'm
still.
also here in Vivekananda, sir.
Okay. 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 Good. Good
Nice
to
to
see
see you,
that you are
sir.
there. in the same college where my very good friend Dr. Davnia is there. You must be getting a lot of good guidance from him.
So I expect Rasika to start a company tomorrow.
Sure, ma'am.
Thank
Sure.
you.
With your support and
audible,
blessings,
sir?
this may happen.